We're on Chapter 2, Section 6, which in our course is Learning Plan 1-8. We're doing set operations and compound inequalities. First of all, we're going to find the intersection of two sets, and that means that we'll be able to solve compound inequalities with the word that have the word "and" in them. We're also going to find the union of two sets, and that means we'll be able to solve compound inequalities with the word "or." So the word "and" goes with intersection, the word "or" goes with union. So, how do we find the intersection of two sets? The intersection of two sets is defined with the word "and." If you have set A and set B, the place where the two meet is the intersection, like an intersection on a street. And so we read A intersection B is the set of all x such that x is an element of A and x is an element of B. So here are A and B, find the intersection. So what members are in both of them? Well, I see 5 in both of them, and I see 6 in both of them. So the intersection is 5 and 6. You try this one and see if you can get it. Okay, so they want the intersection of A and B. A and B both have Q in them. They both have S in them. They both have Y in them. And they both have Z in them. So the intersection is QSYV Z, which is the exact same as set B. Sometimes the intersection is one of the two sets. Okay, let's go on and see what we can learn. Now, if we have a compound inequality, we have two inequalities that are linked either by the word "and" or the word "or." So, for example, x plus 1 is less than 9, and x minus 2 is greater than 3. 2x is greater than 4, or 3x minus 6 is less than 5. We're going to learn how to do both of them today, but for right now, let's just concentrate on the ands. How does it work? First of all, you solve each inequality individually. And since the inequalities are joined with the word "and," we want the numbers that satisfy both the inequalities. Okay, solve the compound inequality. So the first thing we're going to do is graph this one. Solve this one, x plus 3. So let's subtract 3 from both sides, and we get x is less than negative 2. Add 4 to both sides here. X is greater than negative 8. There's an "and" in between them. So let's see how it looks on the number line. We have negative 2, and we have negative 8. X is less than negative 2. X is greater than negative 8. So in other words, it's just going to be the area between those two. And so we would write parentheses negative 8, comma, negative 2, close parentheses. Let's try the next one. Okay, so here's our number line. We're going to be greater than 2. X is greater than 2. X is greater than negative 3. Oops, this is positive 2. So this area right here, while it is true that it's greater than negative 3, it's not greater than 2. It's got to be both. And so the area we're going to be shading is over here, parentheses 2, comma, infinity, close parentheses. And that would be letter D here. Next one. Okay, so first off, we're going to subtract 2 from each side. We get x is greater than 1. Subtract 1 from each side, and we get 2x is less than negative 4. Divide both sides by 2. X is less than negative 2. So we've got our 2 points are at -2 and 1, let's see what happens at those 2 points. X is greater than 1. X is less than -2. Well, if you notice, there's nothing that fits, and so we would say the null set for that one because there are no places where they overlap. Next one. So the first thing we're going to do, 6x plus 6 is greater than or equal to 24. Subtract 6 from each side. 6x is greater than or equal to 18. Divide by 6. X is greater than or equal to 3. Second one, 6x plus 6 is less than or equal to 48. Subtract 6 from both sides. 6x is less than or equal to 42. Divide both sides by 6. X is less than or equal to 7. So our two critical values are at 3 and 7. X is greater than or equal to 3. X is less than or equal to 7. So we've got brackets at both ends. And it looks like this one right here, which means that we would have bracket 3, 7, close bracket. So that's intersections. Now let's go on and deal with unions of sets.